Welcome, grade 11s. This is the continuation of what we talked about last year under electricity and magnetism. So we talked about electrostatics. Now remember, electrostatics is about the polarity of the charges. And then we talked about the incidence whereby now we can rub two objects together. And then there is a transfer of electrons that is taking place. And then we remember that the one that loses electrons becomes positively charged, and then the one that gains electrons, therefore it has electrons in excess, therefore we said it becomes positively charged. We also now talked about the forces between the charges. We talked about the positive charge and the positive charge. And then now when we bring them closer together, they are going to repel, which means they are going to push one another away. The moment you're saying push one another, which means therefore now you are referring to a force. Remember, by definition, a force is a push or a pull. And then we also have a negative and a negative charge. Then when you bring them together again, they repel, which means they push one another away. Therefore, we say now positive and the positive, they are alike. They look the same. They are the same. They are similar. So we say therefore similar charges repel. And then now you have the positive and the negative charge. Then you bring them together. Then they attraction. So again now we're saying, okay, they pull one another. Pull, attraction means pull one another closer. So pull means again force, which means therefore now, which is why we're saying the forces between the charges. Now this brings us then now to the new concept of Coulomb, Coulomb's law. Now Coulomb's law simply says now, okay, suppose now we have a negative charge and a positive charge. Name it charge 1 and 2. And then now you bring them together, but then now they are a certain distance apart. Now what is going to happen? You are going to see that charge 2 will pull charge 1 by the force F21. And then charge 1 will apply the very same force, but now will pull charge 2 by F12. Now, which means that this is where now we can say Newton's third law is applicable. Newton's third law applies here. Then now, okay, we say, in short, mathematically now we can say the force of attraction between two charges is equals to this K. This K is a constant. It's called the Coulomb's constant. And then now charge 1 multiplied by charge 2 divided by R squared. Now this R is the distance between the two charges. Now you will note that for attraction, suppose we have these two opposite charges. For attraction to be much stronger, we did that experiment in grade 10. For attraction to be much stronger, we need to bring the two charges closer. We need to bring the two charges closer, which is why then now I say, okay, this charge is inversely proportional to the square of the distance. Or we can say it is directly proportional to the inverse of the square of the distance between the two charges. Because now if you want to weaken the force between the charges, what do you need to do? You need to increase the distance R. But again now, if the charge is bigger, the bigger the charge is, Therefore, we're saying now the attraction is going to be stronger. I think there's something in your mind when I talk about this. The law, like the Newton's universal law of gravity. Please never confuse the two. The other one is about the masses. This one is about the charges. And then again we have G. Here we have K. Two different constants, two different values. Now, in words, we can say Coulomb's law. The force of attraction or repulsion between the electric charges. Here it's between electric charges. Between the electric charges that are at rest is directly proportional to the product. See here, you multiply the product to the product of the charges and inversely proportional to the square of the distance between them. So now between their centers, Now you see it's more or less singular. Just that now here we're talking about the charges, but with the universal law, we're talking about the masses. So then now we can say here, this F, this is the force between the charges. The force between the charges is measured in newtons. And then now this is charge 1 and charge 2. They are they measured in coulombs. And we can say, okay, let me start a new slide here. We said the force between charge 1 and charge 2 is measured in newtons. And then charge 1 and charge 2 are measured in Coulomb. And then we have the distance between distance. This is the distance. The distance between the charges is measured in meters. Please, not centimeters, not cm, not millimeters, but meters, measured in meters. Then we have K. This is Coulomb constant. And the value is 9 times 10 to the power of 9. Then is measured in newtons meter squared per square coulomb, or Coulomb squared. You can say that per Coulomb squared. Now, we are going to talk about that now. We are going to talk about the application. The application then of Coulomb's law. I'm sorry about the camera. I'm sorry about the camera. I don't have enough equipment to hold the camera and so forth. I'm very sorry about that. Applications. You can see it is not stable. Application of Coulomb's law. Applications of Coulomb's law. Now, the application of Coulomb's law, it's either we're talking about the linear applications, which means therefore now we're saying linear, we're saying one-dimensional. It's either one-dimensional or two-dimensional. Now, we are only going to talk about these two, one-dimensional or two-dimensional. For instance, suppose now you have charge of 3 microcoulomb. It's a positive charge, say charge A. We have charge of another of 3 microcoulomb. You have another charge of negative 2 microcoulomb. Now it's A, B, it's C. Then now you see the distance between this and this is that, say R2. Distance between this and that is going to be R1. Now, even here, you are talking about a force, which means now you must find the force between this and this, then find the force between this and this. Now, as you can see now, the force that is being applied by A on B is going to be a repulsive force, which means therefore now A is going to push B away. And then now the force that is going to be applied by C on B is going to be pulling force, which means therefore now C is going to be to pull B towards itself. Now, the resultant force here is going to be now the resultant force. Remember, force is a vector. The resultant force here is going to be therefore the force applied by A on B plus the force applied by C on B. Now you see here, the very same way you are dealing with the vectors, Newton's laws and so forth, we are also doing the same here. I hope this is clear. Now let us have a look at this one. Two-dimensional. 2 dimensions. Suppose now you have these 3 charges. Positive 3 microcoulomb, negative 2 microcoulomb, and positive 3 microcoulomb. Now, we are only interested in this charge, negative 2 microcoulomb. Call it B. A, B, C. Now, how is the electrostatic force on B due to A? On B due to A. So suppose now this is B. You see here now, A is positive, then B is negative, which means that now A is going to pull B to the left. Therefore, now this is the force, pull, this is the force of A on B. And then now, how is C force of B of C on B? C is positive, therefore C is going to pull B downwards. So this is the force of C on B. But if the two forces are simultaneously applying on B, therefore now this simply means B is going to move in such a way. Remember now, Newton's second law. We are only interested in what? In the resultant force, F net. The object B is going to accelerate in the direction of the resultant force. Where is the resultant force? This is not the tail-to-tail method. So therefore, you must complete the parallelogram. So therefore, now B is going to move in the direction of interesting, right? In the direction of of the resultant force. This is the resultant force, F net. Then now, which means here we'll be talking about the angles and so forth. So this is then now how it looks like in terms of solving the problems on 2 dimensions. Thank you very much for your attention. Then the next video, I will be showing you how to apply these laws and then how to do the calculations and so forth. Remember, you must subscribe for notifications, and then leave your questions, leave your comments. Then we are going to go live on Zoom so that we can discuss the questions. Then we were also going to go to the classroom, Google Classroom. Thank you very much.